In the dead centre of Australia, there is a ring of mountains that should not exist. From the air, it looks like the fossilised eye of the planet itself, a perfect circle of shattered stone, 5 kilometres wide, rising 200 metres straight out of a flat, cracked desert that stretches for hundreds of kilometres in every direction. There is no other mountain range within sight of it. No foothills. No gradual rise. Just an abrupt, violent ring of rock, standing alone in the silence of the Outback, as if something enormous had been dropped from the sky and left its scar behind. That is exactly what happened. For decades, geologists dismissed this place as the eroded root of an ancient volcano. It wasn't until the 1960s that scientists cut into the rock and found something that made their blood run cold, a mineral signature that only forms under pressures and temperatures that no volcano on Earth has ever produced. Pressures generated by only one known event in the geological record, a cosmic impact of almost unimaginable violence. But here is the part that should genuinely unsettle you. The ring you can see today, the 5-kilometre circle of jagged stone tourists now walk through, is not the crater. It is only the very centre of it. The original wound in the Earth's crust was over 22 kilometres wide enough to swallow an entire modern city, and the layer of rock you are standing on, if you visit, is not even the original ground. 2 full kilometres of solid stone above your head has been erased by time, scoured away by 142 million years of wind and rain, revealing the deep, twisted roots of an impact so powerful it reshaped the crust of an entire continent. The Western Arrernte people, who have lived beside this place for tens of thousands of years, never needed a laboratory to tell them what happened here. They already knew. Long before Isaac Newton, long before the concept of an asteroid existed in Western science, their oldest stories describe, in devastating detail, something falling from the stars and striking the Earth with world-altering force. This is Tnorala. The Western world calls it Gosse Bluff, and what scientists eventually confirmed here didn't just rewrite a geology textbook, it forced an uncomfortable, humbling question. How did people with no telescopes, no seismographs, and no written language describe an asteroid impact with terrifying accuracy, thousands of generations before anyone could prove it happened? There is no comfortable answer to that question. Either it is an extraordinary coincidence on a scale that strains belief, or it is proof that human memory, carried carefully enough across enough generations, can preserve the record of a catastrophe long after every eyewitness and every written account has turned to dust. By the end of this video, you will understand exactly why the researchers who study this place no longer treat that second possibility as far-fetched. If this is your first time here, welcome. This channel is dedicated to the places on Earth where geology, deep history, and ancient human memory collide, the mountains, craters, and lost landscapes that hide a true story stranger than any myth built around them. If that sounds like your kind of rabbit hole, subscribe now, because we go deep, and we don't sensationalise what the evidence doesn't support. Now let's go back 142 million years, to the moment the sky opened over central Australia. To understand Gosse Bluff, you first have to understand just how deceptive it is to the naked eye. Most people who see photographs of it assume they are looking at a small mountain range, a modest circular ridge sitting in the desert, unremarkable next to the towering red monoliths Australia is famous for. That assumption is precisely what fooled geologists for the better part of a century. The structure sits roughly 175 kilometres west of Alice Springs, in the southern Northern Territory, in a region of Australia so remote and so sparsely populated that the nearest town of any size is hours away by unsealed road. The land around it is the missionary plain, flat, dry, covered in spinifex grass and mulga scrub, broken only by the distant blue haze of the James Range and the MacDonnell Ranges on the horizon. And then, without warning, the Earth rises. A near-perfect ring of jagged, broken hills erupts out of that flatness, climbing to roughly 180 metres above the surrounding desert floor, forming a closed circle nearly 5 kilometres across. Walk into the centre of that ring today, and you find yourself standing inside a natural amphitheatre of shattered red and grey rock, walled in on every side, the outside world completely vanished from view. It is disorienting in a way that is difficult to describe until you've experienced a landscape that behaves like nothing else nearby, geometrically wrong in a country defined by long, weathered, irregular ranges. For most of the 20th century, the leading theory was that Gossy Bluff was the deeply eroded remnant of an ancient volcanic complex, perhaps a collapsed caldera, its violent shape explained away as the scar of magma and pressure from within the earth. It was a reasonable guess. Central Australia does have a long volcanic history in some regions, and circular structures are common signatures of collapsed volcanic systems. But in the 1960s, geologists studying the rock at Gosse Bluff found something a volcano cannot produce. Buried in the stone were shatter cones, delicate, fan-shaped fracture patterns that radiate outward from a central point, visible only under specific conditions. Shatter cones are now recognised by geologists worldwide as one of the most reliable diagnostic fingerprints of a hypervelocity impact event. They form only when rock is subjected to shock pressures of billions of pascals in a fraction of a second conditions that occur naturally on Earth in exactly one scenario, something from space moving at tens of kilometres per second, slamming directly into the crust. The conclusion was unavoidable. Gossy Bluff was not a volcano. It was an impact structure, and a colossal one. Subsequent research narrowed down the story further. Scientists now estimate the impactor most likely a comet, though some models suggest a dense asteroid was roughly 600 metres wide when it struck, moving at a velocity that would have delivered, in an instant, more explosive energy than the entire combined nuclear arsenal of every country on Earth. The event has been radiometrically dated to approximately 142.5 million years ago, placing it right at the boundary between the Jurassic and Cretaceous periods, a time when dinosaurs still walked the Earth, long before Australia had drifted into its current position, long before the vast. Dry interior we know today had even fully formed. The crater this impact carved into the crust was staggering, estimated at 22 kilometres in diameter, among the largest confirmed impact structures anywhere on the planet. What we see today, that 5-kilometre ring of broken hills, is not the original crater rim at all. It is the central uplift, the deep, compressed core of rock that rebounded violently upward in the microseconds after impact, the way a drop of water leaps back up after a stone is thrown into a still pond, except frozen forever in solid stone. Everything above it, nearly 2 kilometres of rock that once buried this uplift, has since been stripped away by well over 100 million years of relentless erosion, exposing structures that would normally remain hidden many kilometres beneath our feet. Think about the timescale required for that alone. 2 kilometres of solid rock, gone not blasted away in the impact itself, but worn down afterward, grain by grain, by wind and by the rare violent desert rains that occasionally sweep through Central Australia. It is a process so slow it is almost impossible for the human mind to hold on to meaningfully roughly 14 micrometers of rock removed per year, on average, compounding across 142 million years, until an entire mountain's worth of stone had simply vanished into dust and been carried away, grain by grain, on the wind. In other words, the ring of mountains tourists walk through today is not the crater's edge. It is its exposed heart, a piece of the deep earth, thrust violently upward and then slowly unveiled by time, standing now in open air for the first time in over 140 million years. To grasp the scale of what happened here, it helps to compare Gossy Bluff to structures scientists more commonly discuss. Its original 22-kilometre diameter puts it in the same size class as some of the most consequential impact structures ever documented on Earth, larger than the crater linked to the Tunguska scale devastation event, and comparable in scale to several structures associated with regional mass extinction pressure in the geological record. This was not a minor meteor strike. It was a strike capable of measurably altering the local geology, chemistry, and even the topography of an entire region of the continent, the effects of which are still being mapped by researchers today. The colour and texture of the rock itself tells its own part of the story. Walk the exposed faces of the inner ring, and you find a chaotic jumble of sandstone and quartzite, twisted and fractured at angles that should never occur naturally in undisturbed sedimentary rock layers that were laid down gently over millions of years on an ancient seabed, then instantaneously wrenched, folded, and thrust vertically in a moment lasting only seconds. Geologists describe this kind of deformation as shock metamorphism, a category of geological transformation that exists almost exclusively at impact sites. In the harsh light of the central Australian sun, the exposed stone shifts from rusted orange to deep grey to near black, depending on the angle and the mineral composition, giving the ring a strange, almost bruised appearance from a distance, as if the land itself still bears the mark of the injury. The surrounding missionary plain, by contrast, is almost defiantly ordinary flat, sun-baked clay pans, scattered mulga trees, hardy spinifex grasses, and the kind of relentless, shimmering heat haze that defines the red centre for most of the year. That contrast is precisely what makes the crater so visually arresting. There is no gradual transition, no foothills easing the eye upward. The land is flat, and then, abruptly, violently, it is not a geological non sequitur, standing in the middle of one of the most geologically stable ancient landscapes on the planet. Long before any European surveyor set eyes on this place, long before the words impact crater existed in any language, the Western Arrernte people already had an explanation for Tnorala. And what makes their story extraordinary is not merely that it exists, it's how eerily it mirrors the violence the rock itself would later confess to science. In Western Arrernte tradition, Tnorala is a sacred site tied to one of the oldest and most cherished narratives in their cosmology, the story of the Milky Way dreaming. In the dreamtime, a group of celestial women danced across the night sky, their movements forming the great glowing band we now call the Milky Way. As they danced, one of the women, growing tired, set her sleeping baby aside in a turner, a wooden basket used to carry infants, sometimes called a coolerman. She rested it carefully at the edge of the dance ground, high above the earth, and continued the ceremony with the others. But the dancing grew wilder. The sky floor shook and rocked beneath the women's feet, faster and faster, more violent with every step, and the turner, resting precariously at the edge, was jolted loose. It toppled from the heavens and fell, carrying the sleeping infant with it, plunging down through the sky toward the earth far below. When the turner struck the ground, the force of the impact was so immense that it drove the rock upward from beneath the surface, forcing stone into the air and forming the circular wall of mountains that stand at Tnorala to this day. The baby was buried beneath the shattered earth, hidden from the world. And to this day, in Arrernte tradition, the baby's parents have never stopped searching. The mother became the evening star, the father became the morning star. Each night, as they rise and set on opposite horizons, they are still, according to the story, searching the sky and the earth for the child they lost, a search that has continued, unbroken, since the beginning of time. Sit with that story for a moment, next to the geology. An object falls from the sky. It strikes the earth with such catastrophic force that solid rock is thrust violently upward, forming a ring-shaped mountain range. The impact buries what fell beneath tons of shattered stone. This is not simply a poetic myth loosely gesturing at a mountain. This is, in structure and sequence, a description of an impact event cause, mechanism, and result passed down for uncounted generations among a people who had no way to verify it scientifically, and yet arrived at an explanation that modern geology would not confirm until the 1960s. Tnorala is not treated as folklore by the people who hold this story. It is a registered sacred site under Australian law, and it remains one of deep spiritual significance to the Western Arrernte today. Certain areas within the crater are restricted, accessible only to initiated members of the community, and particular ceremonies and knowledge connected to the site are not shared outside Arrernte law. Visitors are welcome to the reserve, but they are asked clearly and respectfully to stay on marked paths, to photograph only where permitted, and to understand that they are walking through a place that is, to the traditional owners, not simply a geological curiosity, but a living, sacred narrative still being told. It's worth pausing here to reject a lazy assumption that creeps into far too many documentaries about places like this, the idea that ancient peoples were simply guessing and got lucky. That framing does a disservice to the sophistication of oral tradition. Aboriginal dreaming stories across Australia have increasingly been recognised by researchers, including astronomers, as containing detailed and accurate observational knowledge passed down with remarkable fidelity across thousands of years, sometimes encoding astronomical events, sea level changes, and geological processes that modern science has only recently been able to independently verify. Tnorala is one of a small number of sites in Australia where Aboriginal oral tradition and confirmed impact geology now sit side by side, telling the same story through two entirely different languages, one written in stone and one carried, unbroken, in memory. The Western Arrernte did not need shadow cones or radiometric dating. They watched the land, they listened to what was carried down to them, and they understood, long before anyone else on earth could prove it, something fell here, something violent, and it changed this place forever. It is also worth noting how the story is embedded within a much larger web of Arrernte knowledge about the surrounding country. Tnorala does not stand alone in the dreaming as an isolated tale about one mountain range. It connects outward to the paths the celestial dancers are said to have taken across the sky, to neighbouring sacred sites along the same songline, and to a broader cosmological framework in which the landscape itself is understood as a living record of ancestral action. This is a crucial distinction that outside observers frequently miss. The story of Tnorala is not a standalone folk tale invented to explain a strange rock formation. It is one anchor point within a continuous, structured system of law, geography, and memory that has been maintained, taught and renewed by successive generations of custodians for an extraordinary span of time, a system some researchers now believe may represent one of the longest continuously maintained oral records held by any culture on Earth. That context matters when we consider just how precisely the story maps on to the physical evidence. This isn't a single lucky guess buried among 1,000 wrong ones. It sits inside a broader, internally consistent tradition of careful, transmitted observation about the land, a tradition that when checked against the modern geological record at Tnorala and at other Arrernte impact sites such as the nearby Henbury craters, keeps producing the same unsettling result. The ancient explanation and the scientific one are describing the same event. The recorded history of Gossy Bluff, in the sense that Western documentation understands it, begins far later than the story deserves, and even then, it begins with confusion, hardship, and a series of encounters that hint at just how disorienting and dangerous this landscape can be to those who don't understand it. 1872, the naming. The first European to lay eyes on the crater was the explorer Ernest Giles, during one of the punishing overland expeditions that opened up the interior of Australia to colonial mapping. Giles and his party were operating in brutal conditions, extreme heat, scarce water, and terrain that had already claimed the lives of other explorers attempting to cross the continent's arid centre. When Giles spotted the strange, isolated ring of hills rising from the plain, he named it after William Gosse, a fellow surveyor. What Giles could not have known is that he was staring directly into the shattered core of a 142-million-year-old cosmic wound. He simply recorded it as an unusual range, and moved on, unaware he had just become the first person in written history to document one of the most significant impact structures on the planet. The early 20th century silence. For decades after Giles's expedition, Gossy Bluff remained almost entirely unstudied. Its extreme remoteness, combined with the sheer difficulty of travelling through the surrounding desert, meant that few outsiders ever ventured close. It sat, largely undisturbed, known intimately to the Western Arrernte, and almost entirely forgotten by the wider world, a 200-metre wall of stone standing in one of the loneliest landscapes on Earth. The petroleum years' dry holes and dead ends. That isolation broke in the mid-20th century, when oil and gas exploration companies, chasing the theory that the structure might be a collapsed volcanic caldera capable of trapping hydrocarbons, moved equipment into the site and drilled exploratory wells near its centre. It was expensive, difficult work in a punishing environment, and it produced nothing. The wells came up dry, again and again. At the time, geologists chalked the failures up to bad luck, or a flawed read of the local rock structure. It would be years before anyone understood the deeper reason those wells failed. The men drilling into Gossy Bluff weren't tapping into an ancient volcanic reservoir at all. They were drilling into the shattered, chaotic, pressure-fractured remains of an asteroid strike, a geological environment fundamentally unlike anything their models were built to predict. The abandoned wellheads, quietly rusting near the crater's centre, remain there to this day, a strange monument to an industry that misread the ground beneath its feet. The 1960s, the discovery that changed everything. It was during renewed geological surveys in this period that researchers first identified the shatter cones buried in the crater's rock, the discovery that finally forced the scientific community to abandon the volcanic theory and confront a far stranger truth. Aerial and later satellite photography showing the crater's eerie. Perfect circularity from above only reinforced how unmistakably artificial the structure looked against the surrounding desert, a geometry far too clean to be explained by ordinary erosion or volcanism. For geologists who had spent careers describing this place in the wrong language entirely, it was a genuinely disorienting moment, the sudden realization that the ground beneath their boots had not simply been shaped by fire from within the earth, but scarred from above, by something that had crossed millions of kilometres of empty space to get here. The 1970s and 80s scientific pilgrimage. As word of the confirmed impact spread through the international geological community, Gossy Bluff became something of a pilgrimage site for planetary scientists, a rare, accessible, well-preserved window into the deep structure of a large impact crater, without the need for expensive drilling or space missions. Researchers studying the moon Mars. And Mercury began using the exposed rock at Gossy Bluff as a natural laboratory, comparing its shock metamorphosed stone directly against samples returned from the Apollo missions, since the physics of a hypervelocity impact behaves consistently whether it strikes Earth, the Moon, or anywhere else in the solar system. In a very real sense, this remote Australian desert became one of the places where scientists learned to read the scars left behind by cosmic violence knowledge later applied to understanding craters on worlds no human has ever set foot on. Modern accounts, the unsettled feeling. Even today, visitors and researchers who walk into the centre of Gossy Bluff frequently describe the same disorienting sensation, the sudden, complete loss of the horizon, the way sound seems to behave strangely inside the enclosed ring of stone, and an overwhelming instinctive sense of having stepped into somewhere fundamentally separate from the world outside. There are no verified reports of disappearances at Gossy Bluff. This is not and has never been, a site associated with missing persons cases. But the psychological effect the crater has on people who stand inside it is consistently, almost universally, described the same way: a closed-in stillness, an eerie enclosure, a landscape that feels less like a mountain range and more like standing inside the aftermath of something enormous. Traditional owners have long asked visitors to treat the site with caution and respect, not because of any supernatural threat, but because the terrain itself, the isolation, and the extremity of the desert climate make careless behaviour here genuinely dangerous. A warning that, as we're about to see, science would eventually validate in full. Now, if you're waiting for this to turn into a story about alien landing sites or paranormal energy fields, I want to be upfront with you, it doesn't. What researchers actually found when they investigated the rumours swirling around this crater is, in its own way, far stranger and far more sobering than anything supernatural. Stick around, because the real explanation reshapes how we should think about ancient warnings altogether. And if you want more deep dives like this, subscribe now, we're just getting started. Any landscape this strange, this isolated, and this visually alien inevitably attracts speculation that has nothing to do with geology. Over the decades, Gossy Bluff has picked up its fair share of fringe theories, fueled largely by its uncanny, almost engineered appearance from the air, a perfect ring sitting in total isolation, unlike anything else for hundreds of kilometres. The most persistent rumour, unsurprisingly, involves extraterrestrials, not the idea that aliens caused the crater, but the claim. Circulated on forums and low-quality ancient mysteries content for years, that the structure is somehow artificial, a landing site, a base or evidence of advanced technology buried beneath the rock. This theory collapses immediately under scrutiny. The mineralogy of Gossy Bluff has been extensively studied by planetary geologists, and it is entirely consistent. Down to the microscopic structure of its shatter cones, with dozens of other confirmed natural impact craters found across the globe, from the Chicxulub crater linked to the extinction of the dinosaurs, to Germany's Rise crater, to Wolfer Creek elsewhere in Australia. There is nothing in the geological record here that departs from natural asteroid or comet impact processes. The ancient alien base theory isn't supported by a single verifiable data point. It survives purely on the visual drama of the crater's shape, not on evidence. A second theory, somewhat more grounded but still largely unsupported, claims the crater sits atop a powerful magnetic anomaly, similar in nature to some Bermuda Triangle folklore, allegedly capable of disorienting compasses, aircraft instruments, or even human cognition. Geophysical surveys of the region do show some localized magnetic variation, which is entirely expected impact events dramatically alter the physical and mineral structure of the rock they strike, sometimes producing measurable changes in magnetic susceptibility. But these variations are minor, well within the range seen at other impact structures worldwide, and nowhere near strong enough to meaningfully affect navigation equipment or produce any of the disorientation effects visitors describe. The unsettled, closed-in feeling reported by people standing inside the crater has a far more mundane explanation. One we'll get to shortly, and it has nothing to do with magnetism. A third, more recent rumour ties Gossy Bluff loosely into the broader online mythology of Australia's Outback as a kind of vortex-laden mystery zone, lumping it in with unrelated stories from Uluru and other remote sites, suggesting some shared, unexplained energetic property links these locations together. Anthropologists and geologists studying these sites have consistently pushed back on this framing. What actually connects these places is not a mysterious energetic field, but a documented pattern. Many of Australia's most geologically extraordinary landmarks also carry deep, independently developed significance in Aboriginal culture. Because ancient peoples were remarkably attentive observers of their landscape, drawn to record and pass down stories about the most visually striking, unusual, and geologically significant features around them. That is not a mystery. It is a testament to careful, long-term observation, sustained across thousands of years, arguably one of the most sophisticated environmental record-keeping traditions on Earth, dismissed too easily by outside observers looking for something more exotic. When actual researchers, geologists, planetary scientists, and anthropologists working with Arrernte custodians investigated Gossy Bluff seriously, what they found was not a paranormal mystery to be debunked, but something more interesting, a rare case where a scientifically confirmed catastrophic event and an independently preserved oral tradition point to the exact same conclusion. The supernatural theories don't hold up. The evidence for the sacred story does. It's also worth addressing directly why fringe theories latch onto places like this in the first place. Isolated, visually dramatic landmarks, with a genuine element of documented mystery in this case, the century-long confusion over whether the crater was volcanic or cosmic create fertile ground for speculation, especially once footage of the crater's uncanny circular shape started circulating online, stripped of its scientific and cultural context. Without that context, a perfect ring of mountains sitting alone in the desert looks, to an untrained eye scrolling past a 10-second clip, like something that demands an exotic explanation. With the context, the explanation is arguably more astonishing than any of the invented ones. A piece of deep space, larger than most office buildings, struck this exact patch of Earth with enough force to punch through kilometres of solid crust, and a human community, watching from generation to generation, kept that memory alive until science finally caught up to confirm it. So if it isn't aliens, and it isn't a magnetic anomaly, why does Gossy Bluff carry such a powerful, unsettling reputation, and why have the Western Arrernte treated it with caution and reverence for thousands of years? The answer, once you understand it, is almost more unsettling than any supernatural explanation, because it is entirely verifiably real. The first truth is the sheer physical danger of the landscape itself. Central Australia's interior is one of the most punishing environments on the planet's summer temperatures, regularly exceeding 40 degrees Celsius, extreme aridity, and a terrain that offers almost no natural water source for enormous distances in every direction. Explorers like Ernest Giles didn't merely find this land difficult. Expeditions across this exact region, in this exact era, were among the deadliest in Australian colonial history, with dehydration, disorientation, and exposure claiming lives with terrifying regularity. Walking into Gossy Bluff unprepared, even today, means walking into a landscape with essentially zero margin for error, no shade for kilometres, no reliable water, and a punishing sun that can turn a minor miscalculation into a life-threatening emergency within hours. The second truth lies in the crater's structure itself. That closed-in, disorienting sensation so many visitors describe when standing at the centre of the ring isn't paranormal, it's a direct, measurable consequence of the impact geometry. Standing inside a nearly enclosed 180-metre high circular wall of shattered rock genuinely does cut off the horizon in every direction, disrupts normal sound propagation, and removes the ordinary spatial reference points the human brain relies on to orient itself in open landscape. This is not a mystical vortex. It is simply what it physically feels like to stand inside the exposed core of an asteroid, impact a landform so violently different from ordinary terrain that the human nervous system reacts to it as somewhere fundamentally alien. Because in a very real sense, it is. The third truth, and perhaps the most humbling, concerns the terrain hazards hidden throughout the crater's interior. The shattered, fractured rock left behind by the impact, the very same shatter cones that proved this, was a cosmic collision, creates deeply unstable, jagged ground riddled with hidden crevices, loose rockfall, and unpredictable footing. This is precisely the kind of terrain where a simple fall, miles from help, in extreme heat, with no phone signal and no passing traffic, can escalate from a minor injury into a genuine survival crisis within a matter of hours. It's a landscape that punishes carelessness swiftly and without mercy, not through any curse, but through pure, unforgiving physics and geography. Taken together, this is what makes Gossy Bluff genuinely dangerous, not aliens, not magnetism, not a curse, but the collision of extreme climate, disorienting terrain, and profound isolation, layered directly on top of the site's deep spiritual significance. And this is exactly why the Western Arrernte people have treated Tnorala with such careful respect for generations, not out of superstition, but because their ancestors understood, through long, hard-won observation, precisely how unforgiving this place could be to those who approached it without care. Science did not disprove the ancient warning. It confirmed it in exhaustive technical detail. There is a broader pattern worth naming here, one that repeats across dozens of sacred and restricted sites throughout Aboriginal Australia. Time and again, places marked as dangerous, restricted, or requiring particular ceremony and preparation before entry turn out, on close scientific inspection, to correspond with genuine physical hazards, unstable ground, extreme thermal risk, flash flood-prone terrain, or, as at Tnorala, a combination of disorientation and isolation capable of turning a minor mistake fatal. What looks, from the outside, like ancient superstition frequently reveals itself, under scrutiny, to be a sophisticated risk management system encoded into cultural lore, passed down not as blind fear, but as hard-earned, practical knowledge about a landscape that offers no forgiveness for carelessness. Tnorala is one of the clearest, most well-documented examples of that pattern anywhere on the continent. What makes Gossy Bluff so remarkable, in the end, isn't a single shocking discovery, it's the quiet convergence of two entirely different ways of understanding the world, arriving, independently, at the same truth. Western science needed shatter cones, radiometric dating, and satellite imagery to confirm what the Western Arrernte had already encoded into a story about a falling child and two searching stars, passed down across an unbroken chain of generations, stretching back tens of thousands of years. Neither version diminishes the other. Together, they tell the complete story of a single catastrophic moment 142 million years ago, still written into the land, and still remembered in the sky. Perhaps the most humbling lesson Tnorala offers is this: the line we so often draw between myth and science, between ancient story and modern evidence, may be far less solid than we assume. One is written in stone and confirmed with instruments. The other is written in memory and confirmed through generations of careful, disciplined transmission. At Gossy Bluff, both point, without contradiction, to the same violent afternoon, buried 142 million years in the past, a reminder that long before laboratories existed, human beings were already watching the sky, and already remembering what they saw fall from it. That's the story of Tnorala, the Gossy Bluff crater. What do you think does it change how you look at ancient oral traditions? Knowing how precisely this one lines up with the geology? Let me know in the comments, and if you want more deep dives into the places where ancient memory and modern science collide, subscribe, and I'll see you in the next one.